So in this example we have another right triangle with a right angle down here in the bottom left corner, and the if I can get my pens to work, the side that is facing that over here is the side with length 12, so that's the hypotenuse. We don't know either of the other angles, so this is different from what we've done previously. But let's say we decide that we're going to deal with A. So we make a decision here as to whether we're going to deal with angle A or angle B. And let's just decide angle A. There's no right answer here, so you have a choice. And let's say angle A is the angle that we're going to deal with. Okay, so let's make a little note of that for ourselves. Dealing with angle A. Okay. So as long as we know that we're dealing with angle A, then the side opposite that is down here. This is the 3. So now we have the hypotenuse and the opposite, so that means this side over here must be the adjacent. Okay, so our job here is just to find the missing angles. So let's say we want to do angle A. We know the hypotenuse. Okay, so the hypotenuse is 12, and we also know the opposite is 3. So you ask yourself, what trigonometric ratio involves a hypotenuse and the opposite? And it's sine. Okay, so if we know hypotenuse and opposite, then we're dealing with sine. So let's say sine of the angle. Remember, it's always sine of an angle. In this case, the angle that we're dealing with is A, so sine of A is equal to the opposite, which is 3, divided by the hypotenuse, which is 12. Now, if you want to, you can break that down and make it 1 over 4, divide top and bottom by 3, but that's sort of up to you. You don't have to do that in this case. Right, so we know that sine of A is equal to 3 over 12. If we have a numerical value, if we know a number answer, in other words, for sine of A, then the way to get A is to get the inverse sine. Okay, if we know sine of A, then we can use the inverse sine. So sine with a little symbol up here, -1, looks like part of -1 or maybe even reciprocal, but it's not. In trigonometric ratios, this -1 has a different meaning. It means the inverse sine of 3 over 12. Okay, so A is equal to the inverse sine of 3 over 12. Now the question told us that we want to work this out correct to 3 decimal places. Anytime you see that, it means you're going to be using your calculator. So let's bring up the calculator. Okay, now just make sure, let's clear this. Let's make sure we're in degree mode. So hit mode, and you can see that on the third line degree is highlighted, so that's okay. So quit that. And now inverse sine. So to get inverse sine, you do second and then the sine button. So that gives you inverse sine and 3 over 12. 3 divided by 12. And close the parentheses. Hit enter. And that's 14.4775. A equals 14.4775, and that would be degrees. Make sure that I've got that right. 4775, yeah. Okay. And then we wanted to do this correct to 3 decimal places. So draw a little line to break it up after the 3rd decimal place. And this is a 5. 5 is enough to push this one up to 478. So A is equal to 14.478 degrees, correct to 3 decimal places. Okay, so we now know that this is 90 degrees. We know that this is 14.478 degrees. We need to find B. Well, remember, if you know one of the angles and you know the right angle, it's easy to find the third angle. You just subtract from 180. Okay, so to find angle B, we just make that equation 180 degrees. The 3 angles in there have to add up to 180 degrees. So we had a right angle, and then we had A, which is 14.478 degrees, plus B. Okay, so if we want to get b on its own, move everything else to the other side. That's 180 minus 90 minus 14.478 is equal to b. And if you do that, you can do it like this: 180 minus 90 minus 14.478, and there's 75.522. 75.522 degrees is equal to B. Okay, and there we have both of the missing angles. Now, didn't look up the adjacent in this question because you weren't actually asked to do it. You were only asked to find the missing angles. Okay, so you don't have to do that last part. Okay, thanks for watching.